Right back. Not a minute to spare. Okay. Okay, so I don't know that we actually did these when we did isosceles triangle theorems, but this is how this works. I think they're neat. They're like little puzzles. Remember that when we have an isosceles triangle, the isosceles triangle angle theorem said that if the two sides were the same, then the base angles would also be the same. So, what we know here is that if these two sides are the same, then these two angles are the same. We know that the interior angles of any triangle have to add up to 180 degrees. 75 plus 75 is 150. 180 minus 150 is 30. That means this is 30 degrees right here. This angle right here, that's a 90-degree angle. 90 minus 30 is 60. Hey guys, look, this is also an isosceles triangle, which means the base angles have to be 60. If two of the angles are 60, all three of the angles are 60. So here, x equals 60. What's up, Cleo? Good, sweetie. Okay. Same general idea here. So we use what we know to solve for x. If this is 63, isosceles triangle, base angles are congruent. What? See, Cleo's really impressed by all the math we're doing, guys. She just said, wow. 63 and 63 is 126. 180 minus 126 is 54. I don't know why I'm doing that, because that's not really germane to this. What? Because we have vertical angles right here, this is also 63. This is also 63. Oh, that's what I was doing. I was solving for x in my head a little bit ahead of time. 63 and 63 is 126. 180 minus 126, 54. So x equals 54. Here, this is 52. So this is 52. We have a right angle here. So this right here, that's 90 minus 52, or 38 degrees. There we go, a decent 38. Next couple ones, we'll amp up the difficulty a little bit. So we have to find what angle 2 is. Once we find angle 2, we plug it in right there, and then we solve for x. So, let's keep going. 71. That's 71. This is 71. 71 and 71 is 142. 180 minus 142 is going to be 38. So it's 38 right here. 90 minus 38, well, that's 52. So we know that the measure of angle 2 is 52. So we can go 52 equals 5x minus 3. Add 3 to both sides. We get 55 equals 5x. Divide both sides by 5, and we get 11 equals x. Same idea here. If this is 64, this is 64. 64 and 64, 128. 180 minus 128, 52. If this is 52, this is going to be 38, because it is 90 minus 52. Now I know that all three of these have to add up to 180 degrees. I also know that these two angles right here have to be the same, because it's an isosceles triangle. So, if I go 180 minus 38 and get 142, that's how many degrees I have to split between these two angles right here. Because it's an isosceles triangle, I know these are equal, so each one of them is going to be 71. That then gives me 71 equals 5x plus 11. Subtract 11 from both sides, and I get 60 equals 5x. Divide both sides by 5, and I get x equals 12. If this is 68, this is 68. 68 and 68 is 136. 180 minus 136 is 44. If this is 44, this is 44. If this is 44, this is 44 because we got another isosceles triangle. 44 and 44 is 88. 180 minus 88 is 92. So that means we got 92 equals 9x plus 2. Subtract 2 from both sides, and we get 90 equals 9x. Divide both sides by 9, we get x equals 10. Yay! 31. Same general idea, except we're using different theorems. So instead of using the isosceles angle theorem, these next two we're going to use the exterior angle theorem and the triangle angle sum theorem. We're also on this one going to use the vertical angle theorem. So we know these two are vertical angles, so that's got to be x plus 80 as well. We know that this adds up to the same thing as this. So we get x plus 65 plus x plus 80 equals 145. That gives me 2x plus 145 equals 145. Don't like where this is heading. Subtract 145. That gives me 2x equals 0. If I divide both sides by 2, I get x equals 0. Normally I'd freak out, except, well, I already did this today, so I know that's the right answer. Plus, if I put a 0 in here and a 0 in here, that gives me a 65 for A, which is correct. And then plus 80 is 145. I know they have to add up to 145, so I feel confident that that's the right answer. Here, we know that all three of these interior angles of a triangle have to add up to 180. That gives me 10x plus 80 equals 180. I subtract 80 from both sides. I'm going to get 10x equals 100. I divide both sides by 10. I'm going to get x equals 10. So, I need to find the measure of angle A. So I'm going to go 4 times 10 equals 40. And call it a day. Not like an actual day, because I have more work to do. But more like a, I'm done with that problem kind of day. Okay. Okay, so we're not actually going to do this part of it. Graph the given line. We do it in slope-intercept. So we start at the y-intercept. We then use our slope, which is 8. So we go up 8 over 1. We're going to use the ruler, which I like. I'm going to draw that line. And take away the ruler. So write the equation, and now we know that, so we have this point right here, 3, negative 2. We need to find the equation line perpendicular. Well, what do we know about perpendicular lines? We know about their slopes. So if the slope of this one is 8, that's 8 over 1. I know that to find the slope of the perpendicular line, I do the opposite reciprocal. So that becomes negative 8 over 1. Stop chewing on my face, cat. Equals, and then we flip it upside down. So we get negative 1/8. Now we have a point here and a slope here. So hey, crazy idea. Let's use point slope form. That's going to give me y minus a negative 2 equals 1/8, negative 1/8, times x minus 3. Salem, knock it off. That gives me y plus 2 equals 1/8 times x minus 3. And that's slope form, and that's good. to graph it, I would put, so negative 1/8. We don't actually have room to go down 1 and over 8. So I can actually go up 1 and back 8 and go right there. And there we go. So one of the things that we're not doing is finding that. That would be done using systems of equations. Since we have our dual equations, we could do it either with substitution or elimination. So we're now past where I got the first time, because this is where it froze. So yay, on to new stuff. And it only took another 40 minutes. So, this is what I do for you guys. So, solving for x. So remember what we need to do is we identify these angle pairs. We got that cheat sheet I gave you. Two parallel lines crossed by a transversal. And then it's got all of the different corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary, alternate same side exterior angles are supplementary. So, assuming that you have that with you, which I am, and I'm not going to redraw it here for you, I just don't have the time nor the want, because I literally have given you guys probably a dozen different opportunities to copy it down. So, I will, however, with a little nod to that, on each one of these, I'm going to identify, do I want to do rainbow? Sure, let's do rainbow for a little bit. The number of the angles. So this right here, this would be angle 3. This down here, this would be angle 5. So if I were to look at the chart, it would say that 3 and 5 are alternate interior angles and that they are congruent. So we go 4 plus 14x equals 88. We're going to subtract 4 from both sides, and we're going to get 14x equals 84. Divide both sides by 14, and we get x equals 6. Yeah, I don't like that rainbow very much. Well, it's not very rainbowy, and it's just kind of... Ooh, bronze. I'm sorry, I'm like a kid in a candy store. So these two right here, yeah, I'm just going to stick with black. These two right here, they are a linear pair. So it's angles 1 and 2. They're a linear pair, they're supplementary. So we know that they're going to add up to 180 degrees. Combine like terms, we get 19x plus 28 equals 180. We subtract 28 from both sides, and we get 19x equals 152. Divide both sides by 19, and we get x equals 8. Yeah, 8. Here we have angles 2 and 6. These would be corresponding angles. Corresponding angles are congruent when two parallel lines are crossed by a transversal. So we get 10x equals 12 plus 9x. It's a pretty simple one. We subtract 9x from both sides. We get x equals 12. 37, we have 2 and 8 here. They are alternate exterior angles, or alternate exterior angles are congruent. So we have 11x plus 4 equals 10 plus 10x. We're going to subtract 10x from both sides. We get x plus 4 equals 10. We subtract 4, and we get x equals 6. If I wanted to check that, I could plug it 6 in there, 6 in there. 6 times 11 is 66. 66 plus 4 is 70. 6 times 10 is 60. 60 plus 10 is 70. So that checks out. It's always a good idea to know how to check your work so that if you ever need to, you can do it. See, now, like, looking at it from here, I don't mind the rainbow so much, but it was annoying me writing it, I guess. So here we have 4 and 6. 4 and 6, if I look on my chart, those are alternate interior angles and also congruent. I'm going to take a sip of coffee then. So this is going to give me 10x plus 7 equals 12x minus 7. I'm going to subtract 10x from both sides. That's a plus. That's not what we're doing. We're subtracting 10x. That gives me 7 equals 2x minus 7. I'm going to add 7 to both sides. And that gives me 14 equals 2x. I then divide by 2. And I get 7 equals x. $39. Hey, look at that. Same position. So we know that they're congruent. Subtract 15 from both sides. Gives me 11x equals 88. Divide both sides by 11, and we get x equals 8. Okay, midpoint of the line with the segment. So the midpoint formula, remember, is xm, ym. So because it's a midpoint, so it is a ordered pair, equals, and what we're going to do is we're going to add the x's, divide them by 2. We're going to add the y's and divide them by 2. So you'll also see xm equals x1 plus x2 over 2. ym equals y1 plus y2 over 2. So here, it doesn't really matter which one you do as x1, y1, and which one you do as x2, y2. The midpoint's going to be the same. So this is going to go -5 plus 2 over 2. 7 minus 7 over 2. That's going to give me -3 over 2. 0. So that would be my midpoint. Because this is 0 over 2, so that goes to 0. If I wanted to, I could also go -1.5, 0. That would be okay too. Here, again, x1, y1, x2, y2. 2 plus a -7 over 2. -5 plus a -6 over 2. That's going to give me -5 over 2 and -11 over 2. And I'm just going to stick there. If I wanted to, I could then divide it and get -2.5 and -5.5. So now we have the endpoint and the midpoint. So it's like if I'm starting 9, 7, let's say is right here, 6, -9 is right here. And so if this is where I start, and this is halfway, I'm looking for the endpoint down here. Okay? So this formula right here is the other endpoint. So we go x2 equals 2xm minus x1, and y2 equals 2ym minus y1. So here the endpoint is going to be your x1, y1, and your midpoint is going to be your xm, ym. Now, unlike the other ones, order does matter here. You can't mix these up because because look at this. If I go back over here, if this was the start and this was the halfway point, I'd be looking for an answer up here. And there's a big difference between these two right here. So here we're going to go 2 times 6 minus, so this is our x2 equals 2 times xm minus x1, which is 9, which is going to be 12 minus 9, which is going to be 3. My y2 is 2 times -9 minus y1, 7. Negative 18 minus 7, negative 25. So the other endpoint is 3, negative 25. Same idea here. This is my x1, y1. This is my xm, ym. So we go 2 times negative 2 minus 5. That's going to be negative 4 minus 5, or negative 9. That's my xm. And then we have my x2. My y2 is going to be 2 times negative 5 minus a negative 2. We got a whole bunch of negatives here, so let's be careful. This turns into negative 10 plus 2, or negative 8. And that's my y2. So if I start here, this is my halfway point. That's going to be my end point. Solve for x. Yeah, we already did these, so I'm just going to let you guys have fun with these. These are exactly the same as these bad boys right here, except instead of solving for the angle, you're solving just for x, so don't even have to find an angle. Okay, so these ones you guys have a little bit of trouble on. So this is, if I want to prove ASA, what piece of information am I missing? So keeping in mind that we have this right here, we know that this angle matches this angle. We know that this side matches this side. So the piece of information that we're missing is that this angle needs to match this angle. If we had that piece of information, we could then say ASA. So what we're missing is angle DCG being congruent to angle CDB. Okay? Here we're looking for side angle side. We have an angle and an angle. We have this side right here. So in order for it to be side angle side, I need this side right here to match up with this side right here. So we go VU is congruent to TB. We're looking for angle, side angle. Now notice where the side is. It's in between the two angles. So we have our angles here and our angles here. So what we're looking for, it has to be that side. If it's another side, it would be angle, angle, side. But because the side here is in between the two angles, on here we need it to look like it's written. So we need VW to be congruent to BC. Side, side, side. We know we have a side here, a side here. We know we have this side shared, so we're looking for these two sides to be the same. DE needs to be congruent to CY. Again, we already did those, and hey, we're basically done with this first page. So I'm gonna, I don't know if you guys can see my battery savers down to 18%. So I'm gonna go grab my charger, hit stop, and I will see you on the second part of this. For those of you guys who, you know what, you guys shouldn't know how to do this, but really quickly, 52 and 52 alone. If this is 127, this is 53. If that's 53, that's 53. 53 and 53, 106, which makes this 74. If that's 74, this is 74. If that's 74, this is 74, which makes this 106. 106 equals 12x minus 2. I'm going to add 2 to both sides. 108 equals 12x. I went and looped over here, divide both sides by 12, and I get x equals 9. Okay, see you on part 3.